The next section is dividing and factorising polynomials. So first we're going to start off with dividing polynomials. You can keep the official CA notes alongside, but I'm just basically going to run through the examples. A wee bit easier if you watch me doing them and trying to follow my existing notes. So the first example is 2x cubed plus 3x squared plus x plus 6 divided by x plus 2. X goes into 2x cubed, 2x squared times. You're basically dividing that by x. Now you take your 2x squared and you times it by these two terms. So 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. Then you subtract. 2x cubed disappears. 3x minus 4x is minus x squared. X minus nothing is x, and 6 minus nothing is 6. Now you go x into minus x squared. So take minus x squared and cancel by an x, leaves you minus x. So like minus x squared cancelled by x gives you minus x is what I'm doing there. Now take this and times it through. Minus x times x is minus x squared. Minus x times 2 is minus 2x. Draw your line, subtract. Minus x squared plus x squared cancels off. It always should do. X minus minus, x plus 2x is 3x, add 6. Now, x into 3x again goes 3 times. So positive 3 up here, times this by 3. 3x adds 6, subtract. So 2x cubed plus 3x squared plus x plus 6 all divided by x plus 2 gives me an answer of 2x squared minus x plus 3. So that's the first example there. Now, if I go back to the notes, the next thing they have is the Factors Theorem. So I'll take you through example 2 to show you what that means. So, the Factor Theorem. If you just look at my notes here. If x minus a is a factor of fx, then fa equals 0. Right, so what does that mean in real terms? So I'm trying to solve this equation. So it's solving a cubic. You've not done this before, so this is all new. Step 1 is to set fx equals your cubic. And then what I'm going to do is I'm going to try to guess a value of a so that this equals 0. So I tend to start with 1, so put in 1, that didn't equal 0. Then I go to minus 1, subbing minus 1 in. And if you look at this one, you get 7 minus 7 equals 0. So that means x equals minus 1, i.e., bring that minus 1 over, x plus 1 is a factor. And if you remember what a factor is, it's something that divides in. So I can take my expression and divide by x add 1. So x into x cubed, again, x cubed divided by x is x squared. So it goes on top. Then you times these by x squared. X times x squared, 1 times x squared. Draw your line, subtract. They will always cancel off. 2x squared minus x squared is 1x squared. Minus 5x minus nothing, minus 6 minus nothing. X into that goes x times. Now times by x. X squared add x. Cancels off as it should do. Minus 5x, take away x is minus 6x. X into minus 6x, so if you want to see what it looks like, cancel off is minus 6, so it pops on top. Times this by minus 6. Draw your line, subtract. So, fx is now, can be written slightly differently. So instead of writing fx as the big long expression, I can write it as the divisor times the top line there. Now, I want to solve this, look back at the equation, I want to have that equal to 0. So I have this equal to 0, and I can factorise this quite nicely. If that doesn't factorise, just use your formula. Set each bracket equal to 0, so x equals minus 1, x equals minus 3, and x equals 2. And that is how you work out the Factors Theorem for that, if I just go back to the notes, so that basically is everything there. Now, the next one is sketch the graph. So it's the same equation, look. I just have to sketch the graph. So let's have a wee look at this. So I know my graph crosses at -1, it crosses at -3, and it crosses at 2. Now, I always put in x equals 0 to work out what the y coordinate is going to be. So just go back up to the start there and put in 0. So 0, add 2 times 0, minus 5 times 0, minus 6. So it crosses the y-axis at -6. And just a matter of piecing it all together there. So positive x cubed. So if I go down and just basically joining the dots. That is that question done. The next question now in the notes is example 3. You're told fx has this factor. So that means something. So example 3. So fx equals 2x cubed plus px squared plus 5x minus 6. And I know it has a factor of x minus 2. So that means that it divides through by x minus 2. And it will go in nice and evenly. So I'll check the question here. Now, with the factor theorem, if I just go back to the first page of the factor theorem where I wrote it out. If x minus a is a factor, then fa equals 0. So I have got my a's basically 2. So if I sub in 2 into this equation, it should give me 0. So 2 to the power 3 is 8 times 2. 2 squared is 4 times p. 5 times 2 minus 6 equals 0. And just working that out, so that gives you 20 plus 4p equals 0. So p equals minus 5. Now the next one from the notes here, it says, find the value of p and hence factorise. So I now know that my fx can be written as 2x cubed minus 5x squared plus 5x minus 6. I know that this is a factor. So I'm going to divide through. You always divide through power 3s. That's how you solve cubic equations. X into this goes 2x squared times. So times by 2x squared. Draw your line, subtract, they disappear. Minus 5x squared, add 4x squared minus x squared. 5x minus nothing, minus 6 minus nothing. X goes into that, so I'm just going to have to move because I'm running out of charge here in a second. I don't want the video to cancel, so plug it in. Right, that'll keep us going a little bit longer. Now, let's see where we were at there. So x goes into that. So again, minus x squared over x gives me minus x times. So times this by minus x squared plus 2x. Draw your line, subtract. They cancel off. 5x minus 2x is 3x, minus 6 take away nothing. X into 3x goes 3 times. So plus 3 goes on top. So 3x minus 6, draw your line, subtract. So my fx can be written as x minus 2 times the top line. And the question asks me to factorise. So I'm going to see if I can factorise this here. X minus 2. So 2x, x, and a 3, and a 1. So 2x and a 3, you would think I can get the minus 1 out of that. But I'm going to show you how that would not work in this case. So minus 3x, add 2x. That gets me minus x, but does not get me plus 3. So that doesn't factorise anymore. So we are finished at this line. Now, the next thing in your notes that you have is the remainder theorem. And if I have a wee look here at my official notes, the Hold on, I should go grab them here. Okay. Now it's over the page, sorry about that. So over the page, remainder theorem. If fx is divided by x minus a, then the remainder is fa. If it equals 0, it's the factors theorem. That does sound very complicated, but it's actually quite straightforward enough. So I'll run through these couple of examples here. So example 4, it says find the remainder when fx equals x4 minus 3x3 plus x squared minus 4 is divided by, in part 1, x minus 2, and in part 2, x add 1. So what you have to do is basically find what x is and sub it in. So it's pretty straightforward. So over here, look, you put x equals 2 and sub it in. So it's 2 to the power 4 is 16. 2 cubed is 8 times 3. 2 squared is 4. Take away 4. And if you work that out there, you get minus 8. So the remainder is minus 8. That's all it is. In this one here, you rearrange it. It's basically what you're trying to do in your head. Imagine equals 0 and bring that over. So x is minus 1. That's where you get your wee value to sub in. So put an x minus 1 in to your fx expression. So minus 1 to the power 4. Minus 1 cubed is minus 1. Minus 3 times minus 1 is plus 1. Minus 1 squared is a 1. Take away 4. So the remainder in this case here is going to be, so I just note that should be wee 3 in there. So as you think about the minus signs. So that's a 5 take away 4, which is a 1. So the remainder equals 1. And that's done out much more neatly for you in the notes. Are just me running through these for you. And the last question I want to look at is example 5. And in this wee one here, just get it up in the official notes. We can see this. There we go. So you're told in example 5, fx equals 2x cubed plus ax squared plus bx add 1. When it is divided by x minus 1. So in my head, I'm seeing that like such, so x is 1. So when it is divided by x minus 1, so if I sub in 1, the remainder is 7. So just sub 1 into that. So it's 2 add a add b add 1 equals 7. A add b equals 3, bring it over, so 4. Read on down the question. When it's divided by x plus 3, so in my head, I'm seeing this. So x equals minus 3. And when you sub that in, the remainder is minus 5. So let's sub that in. So minus 3 cubed is minus 27 times by 2 is minus 54. Minus 3 squared is 9 times by a is just 9a. Minus 3 times b plus 1, and I know the remainder is minus 5. So tidying that up, 9a minus 3b equals, bring that over and add it on, so 54, take away 5, and then take away 1, brings you down to 48. You can divide everything there by 3, just to make it that little bit easier. You can see two simultaneous equations, call this equation 1 and call this equation 2. I always like to write simultaneous equations out side by side. So a add b equals 4 and 3a minus b equals 16. If you add them together, you get 4a, they disappear, 20. So a equals 5. Sub that into, say, the first equation there. So the first equation is a plus b equals 4, b is minus 1, which is what the question was asking. But you will see this much neater if you look at both the official CA notes and my handwritten notes. And just put both of them together for your own.